Hey guys, this is Unit 4, Video 8 on the periodic trend of electronegativity. So we will jump right in. We got a bunch to talk about here. We're on page 20 in your notes. So electronegativity, of course it's going to be difficult for me to kind of write up above it, but I kind of abbreviate this as EN. Okay. This is a big one. You will definitely see this on your Regents exam, and as we get into bonding in our next unit, this is going to play a critical role in terms of things like polarity and the shape of molecules. So keep that in mind. This is one you definitely need to know. So what it means is it's the desire for an element or an atom to gain electrons. Now I want to add something to this, and this is going to be big. The idea with electronegativity is that it happens through bonding. Okay, so these atoms are going to gain electrons through bonding. All right, oops. Okay, so highlight that, star it, make sure you know that this happens through the act of bonding. Kind of the way to think about it is it's a greediness of an atom or an ion for electrons, kind of like the Grinch, right? How he wants to steal everybody's joy and happiness. Same idea here. The higher electronegative atom wants to take the electrons from the lower one. Okay, so we'll kind of get into that more. So nonmetals, they are going to gain electrons, which we already knew this, to achieve their full octet. Think about it, they're to the right of the periodic table, so they have 5, 6, 7 valence electrons. They're much closer to 8 by gaining rather than losing, so they have a high electronegativity, a high desire to pull in those electrons. Okay, so again, I'm going to abbreviate it as En. Whereas metals are the opposite. Okay, they are going to lose their electrons readily to achieve their octet. They are big sharers. They want to just give those up, let them go, because it's easy for them to just lose them to get to 8 rather than try to pull in 6, 7 more. So they're going to have a low, they're going to have a low electronegativity. Okay. Now, values. So there are these really arbitrary values. They've just got assigned to them based on what they've seen in research and bonding and stuff like that. You can find them in Table S of your reference table. They range from 0.0 all the way up to 4.0 being the highest. The most electronegative element is actually fluorine. Okay, and we'll talk about the trend. We'll kind of see that here on the periodic table in a minute. Where the least, now this is going to be a tricky one, okay, the least electronegative element, what do you think that might be? The actual answer to that, guys, is the noble gases. Think about it. They don't want to bond at all, therefore they have no electronegativity value, so they are just kind of chilling there, not doing anything. So if we talk about the least electronegative element in terms of an actual numerical value, that's going to be francium, the opposite corner from where fluorine is. Now, the way that I get my students to remember this is what the most electronegative, and it's going to come in handy when we talk about intermolecular forces later on, is chem is Fon, right? Because like fun, get it? Haha. Fon, F-O-N. Those are the 3 most electronegative elements: fluorine, oxygen, and nitrogen. All right, so we'll come back to that more when we do intermolecular forces in our next unit. So let's talk about the trend for electronegativity now that we know what it is. So the bigger trend here is going to be the opposite of atomic radius. If you think back, atomic radius got bigger as you went down a group. That was the number one trend. Here with electronegativity, it's going to be the period trend. So as you go across a period, All right, it's going to have a bigger impact on electronegativity than going down a group. So electronegativity is going to increase as you go from left to right. Okay, so keep that in mind as we go across left to right. That's what we're talking about here. Now, the reason for that is going to be the increased nuclear charge. Okay, the number of energy levels is going to stay the same, so those valence electrons are not getting any farther away from the nucleus, so those protons, those positive protons, can still have that same pull on those valence electrons. So number of energy levels, or the shielding, right? Shielding is just how close you are to the nucleus, does not increase. Okay, so this is just a figure kind of going from left to right in period 3, from sodium all the way to chlorine. You can see, their values, they increase in electronegativity. It goes up as you go from left to right. This is the bigger trend. Okay, this is the more important trend when it comes to electronegativity. All right, so I'm going to highlight that. I encourage you guys to as well. Across a period, it increases. That's the bigger trend. Again, it deals with that shielding fact. Now, as you go down a group, okay, so like I said, each one of these 4 trends or 5 trends that we're talking about, they're going to have kind of 2 ideas with it. The period trend and the group trend. Down a group, electronegativity decreases. Okay, the reason for that is that now your number of energy levels is going to increase. All right, so that means your shielding is going up. So it's harder for the element to hold on to those valence electrons because they're getting, further and further away from the nucleus and those positive charges. So really what you want to think about here, guys, is as you go down a group, so as you go down this way, look at these electrons, right? So, the 2 are very close to the nucleus here in helium, but then you add in another one, another energy level. Oh, look, now you've got all of these inside electrons here, they're the ones getting pulled in more so because they're closer to the nucleus than the outer ones. So it gets easier to kind of take one of these and remove the outer one. And as you go down, you get further and further away because this is the shielding. The black electrons, the black dots here, that's your shielding effect. So as you go down a group, it's easier to remove because you are further away from the nucleus. Okay, so just to kind of recap, electronegativity is the desire to gain electrons. They want to pull them in through bonding. Nonmetals, so the right of the periodic table, okay, they have a higher electronegativity value. The further left you go, they have a lower because those are your metals. All right, so as you go left to right, has a bigger impact than going down a group. So really, what we want to, if we're going to draw arrows here to kind of summarize this, okay, this guy right here, fluorine, is going to be your biggest one. Okay, so as you go from left to right, it gets larger, and as you go down, it gets smaller. So kind of recap, left to right, you get bigger, and then top to bottom, you get smaller in terms of the value.